Hello. First, I would like to thank the Arduino Week 2022 Organising Committee and specifically Sylvia Galfo for help and support and the opportunity of presenting this project here today. My name's Andrew Ainger and I have been involved in IT since the 1960s. Now that's before even known as IT. I started work at Plessey in Caswell on their R&D side, developing one of the first solid-state cameras, 100 pixels, that's 10 by 10 matrix. But it was very sensitive. Now I moved to regular electronics in London for a couple of years, and then I went to South Africa for 4 years. It was a great time over there. Later, I moved to Marconi and supported some 6,000 PCs and associated infrastructure together with 6,000 individual applications. Now the project we're talking about today is a well monitoring system for ongoing maintenance, or AWSOM for short. Now we've split the talk into 5 main sections. Firstly, the technology that we used and some that we didn't. The aim of the project, where the ideas come from, and the time it has taken so far, and the project status and lessons learned. The project is intended for use and is being used in Tanzania, where Swahili is the main language. Anyway, the technology we intended to use and didn't, but we started using PLCs, relays, logic, hat calculator and acoustic detection circuitry. And lo and behold, in 6 weeks we got a working prototype, breadboard you could say. However, we didn't stop there. For the first 2 years of the AWSOM project, we experimented. We tried listening to the water to derive its flow. We also tried accelerometers, ultrasonics, capacitive methods, thermal methods and impellers. We didn't really want to put impellers or anything in the water flow, as it was felt that could attract mould and other toxins which would be detrimental to its use. More recently, I have been fortunate enough to form a small group of some 25 senior engineers. That's in hardware, software, mechanical, network, even nuclear engineers have all helped and contributed to this well monitoring systems project. We have at least 2 things in common. Firstly, we are all retired, and secondly, we find it, most importantly, we feel passionate enough to spend time, money and effort developing a well monitoring system in this charitable endeavour. The aim of the project, of the AWSOM project, was to improve water availability for rural hand-pumped water wells through targeted maintenance. Now to achieve this, we had to develop a well monitoring system for ongoing maintenance. Now the charity that requested this is the Eleanor Foundation, and they're based in Guernsey. It was agreed that we needed a day-to-day chart with time on the x-axis and litres on the vertical axis, so we could simply view the well status and provide targeted maintenance when and where necessary. We also needed to check that the AWSOM unit itself was functional, and so we viewed the temperature, battery voltage and the daily power cycle time of the AWSOM unit. We then had to make a big decision. If we were to make progress, we had to learn a new language. Now, at our age, it was going to be very difficult, but we bit the bullet, so to speak, and we learnt C++. It's fantastic. The best decision we ever made, and within the first hour of the first Arduino, landing on my doorstep, I actually got an LED to flash. I know, simple, but it was exhilarating. We also wanted to make sure that the AWSOM unit could be retrofittable to any well. Eventually we focused on one of our Arduino Pro Minis based prototypes using a low band Doppler radar module as the main sensor. It's amazing really that the radar unit module cost less than a pint of beer. Anyway, during the next 2 years we refined and tested the Arduino prototype. We tested in the winter, we tested in the summer, we cooked it, we froze it, to try and identify its operational envelope. Testing was key. We didn't want to deliver something to Tanzania that was DOA, dead on arrival. It was tempting to improve continually some of the already functioning modules. However, this activity was resisted as the target was to get something in country as soon as possible. We wanted to make sure the complete end-to-end process was understood rather than individually. Now the next 2 years was spent testing in country, in Tanzania. Now Tanzania is a difficult place to work in, both socially, technically and environmentally. However, the full end-to-end system is now well understood and further developments are already underway. Right, we looked at the technology used and some that wasn't, though shouldn't be considered, but never mind. We looked at the aim of the project, about continued maintenance through well maintenance, well monitoring, and then where the ideas come from through testing and the charity. And we've had an inkling of how long it's taken so far at the time. Now we come on to the project status and the lessons learned in particular. Right, during the project, lessons were learned, well, identified really, as it's up to the individual to learn, but they call them lessons identified. There are many, but the top 5, we feel, are: the first real lesson was power. The initial experiments used a microphone to listen to water flow and performed Fourier analysis to determine the volume of water. However, the power that this took was significantly more than could be provided by the small spout-mounted solar cells, 10 times more. The second lesson could be summarised as: if it ain't broke, don't fix it. There was a great tendency to develop further and improve further already functional subsystems at the expense of time delay. The next lesson was test, test, test. By pushing the system to the extremes of temperature and environmental conditions, we found that we felt we understood the environmental and operational envelope of the AWSOM unit. How wrong we were, but anyway. Fourth, the next lesson was obsolescence. Obsolescence in hardware, libraries, even suppliers. We had to second source things really quickly. And the fifth lesson is: don't assume anything. Yeah, don't assume anything. It was assumed, for example, that all the SIM cards performed in a similar way. They don't. It was assumed that the buck boost voltage regulators performed as advertised. They don't. And it was also assumed, a little bit closer to home this, that all Arduino Pro Minis performed in the same way. They don't. For example, some Pro Minis that we sourced from alternative sources, shall we say, had the wrong bootloader installed. It took us weeks to find that out. Finally, generosity. It is amazing to see just how generous the volunteer team are, not only financially, but also in the time spent developing and discussing the systems in general. My sincere thanks go to all people all over the world that have helped in this charitable endeavour. As I said, is really fantastic. Conclusions. Well, we now have a well system for ongoing maintenance, which is available to deliver SMS, FTP or email. 5 key data points. The key data points are the pump count, that's the volume of water, the battery voltage, the maximum internal temperature, the number of texts sent to date since the reset button was pressed, at the time the unit has been powered up since the last text that day. This data ends up on the website, enabling people to, with the URL, to provide in-country targeted maintenance as and where necessary. As for the future, well, we are already improving several aspects and are starting even to adopt Excel-based machine learning too. When you think about it, the 5 data points provide us with a pattern every day, and these lines add up over time, and this can be used to determine whether the well is poorly or not. This brings us to neural network machine learning aspects. We did produce an animal of a spreadsheet. It consisted of 10 neurons, that's over 100 test neurons, but it was painfully slow. Well, it was 75 megabytes, and every epoch took 30 seconds, and it was 100 epochs per run. But anyway, never mind. It's not that size anymore, and it seems to work quite well so far. But that's another discussion. Now, finally, most of our data is on GitHub. Also, the circuit diagram, the parts list, the technical and training videos are all on www.wellmonitoringservice.co.uk. Well, thanks very much for the opportunity of talking about this. We still feel very passionate about it and excited about its progress and the future. Anybody who wants to help, please give me a call. Thanks very much. Any questions?